Welcome back to Lesson 6.3b, more solving systems of equations using the elimination method. Let's take a look at our first system. We're going to use the elimination method to solve. But look closely. What needs to be done first in order to solve this system using the elimination method? Do you see that the first equation is written in standard form? Is the second equation in standard form? No. The x and the y is going to have to be switched around in order for it to be in standard form. You want both of them in standard form so that the x's line up, the y's line up, and the constant line up so that you can easily add them together. So let's change the order. We'll have this say negative x plus 2y equals negative 19. And now both the equations are in standard form. And we're ready to solve using the elimination strategy. All right, let's take a look at the two equations. I put them both in blue just so that your eyes are drawn to them. In order to add them together and get one of the variables, either x or y, to cancel out, we need opposites. Do you see that up here I have a positive 3x? Down here I could have a negative 3x very easily if I just multiply the second equation by 3. Remember, you're multiplying the x, the y, and the constants. We're kind of distributing that 3 throughout. The first equation will remain the same. 3x plus 4y equals negative 23. So we're going to copy that one down. The second equation, though, I'm just going to put that right up here underneath it, will be negative 3x. 3 times 2y will be positive 6y. And 3 times negative 19, negative 57. And now we are ready to add the equations together. Remember, you are combining or adding. Might need that calculator again. Well, we have opposites in the x's. 3x plus negative 3x, 0. 4y plus 6y is 10y. Now over here we have negative 23, and we're adding negative 57. And that's going to give us negative 80. This will work out nicely for us. I get the y coordinate of negative 8. Now take a look at the answer choices here. Oh, fancy that. This one is the only one that has the y coordinate of negative 8. So right now I'm thinking that the answer is definitely A, but I just want to be sure. So I can go ahead and I can plug that y coordinate into one of the other equations. And then I can just check to be sure that the x value is in fact 3. And if this right here is a negative 8, that would be negative 32. I would just add 32. I'd solve the equation, just be sure that it solves for x. I won't take the time doing that because yes, the answer is A, but if you want to double check your answer, you just want to plug it back in and solve for the other coordinate. So what would the graph of the system look like if you were actually graphing it on a coordinate plane? Well, you're getting an ordered pair here, so they're definitely going to be intersecting lines because we get one solution. All right, let's take a look at example number 2. Solve the systems using elimination. And then, of course, what would the graph of the system look like? So we're interpreting our answer. Taking a look at the system, I have 5x and 10x, and I know I could easily change this into a negative 10 by multiplying by 2. So let's go ahead and do that. So I'm just going to distribute that negative 2 throughout, just multiply everything up here by negative 2. So negative 10x minus 4y, and then negative 2 times 7. And then the second equation will just remain the same. 10x plus 4y equals negative 3. Now I'm just going to get ready here to add the equations, combine them, add them together. All right, well, looks like I have opposites in the x, and so when I add them together, I get 0. Oh, I have opposites in the y. So when I add them, I'm also going to get 0. So on the left side of the equal sign, everything together has a value of 0. On this side, negative 14 plus negative 3 is negative 17. My x canceled out, my y canceled out. I no longer can solve for x or y, and I end up with 0 equals negative 17, which is a not true statement. So what do you think the solution is going to be? Aha, you are right. No solution. There is no solution for this system. So what would the graph of the system look like if there's no solution? Remember, they're never going to touch each other if there's no solution, right? So I'm going to have a set of parallel lines. Those two have the same slope. They're parallel, no solution. So I'm not able to solve for x or y, so I will not get a coordinate as a solution there. Let's look what happens with number 3. Okay, here's our system. I have a 2 and a 3. I could make one of them 6 and one of them -6. I have a 4 and a 6. I could make one of them 12 and one of them -12. Either way, I'm just going to go with the first two. So let's make this a +6 by multiplying by 3. That'll make this a +6x. Then we want to make this one a -6x. So I'm going to multiply by -2 everything. So here I'm changing both equations. So we're going to rewrite both of these equations and just tripling everything up here. So 6x minus 12y equals -18. Just tripled everything there. Now here I'm multiplying by -2. So -6x, -2 times -6 is +12y, and -2 times -9 is +18. Can you see what's going to happen here? All right, getting ready to combine the equations together. These are opposites, they'll cancel. These are opposites. When I add them, they'll cancel, giving me a value of 0 on the left. -18 plus 18, these are also opposites, giving me a value of 0. And I get 0 equals 0. The x and y canceled out, and I have a statement that is true. It's an identity. So what does this mean for the solution? Infinite solutions. Infinitely many solutions, which means I'm going to end up having coinciding lines. If you rewrote both of these equations, y equals mx plus b, they would be exactly the same line. Yes, yes, yes. All right. Number 4. Here we're asked in which system are the lines parallel? So remember, when you have two parallel lines, you have a system that has no solution. Right? So that's what we're looking for. Parallel lines means no solution. Okay, so we're looking at our systems here. Now, if I were to try and get the x to cancel out here, I have to multiply by -2, and the x would cancel out, but would the y's cancel out? Because remember, if I get no solution, the x's and the y's have to cancel out. Now, that wouldn't happen here. What about this? These are opposites already. If I were to add these two and combine them, do you see how these would cancel out, but I get 2x here? That wouldn't cancel out, so that can't be parallel. Here, these are already opposites, right? So they're going to cancel out if I add the equations together, and here I'm going to get 7x. That's not going to cancel out. Let's try this. Here, if I multiply the top equation by -3 everywhere, I'd end up with -6x minus 9y equals -15. The bottom equation would remain the same, 6x plus 9y equals 1. And now if I go to add them together, do you see how the x's cancel, the y's cancel, and I get 0? And then here I'd have -15 plus 1, -14, which would be a no solution, right? So just kind of looking through, I don't really have to solve everything, but I can kind of see here these are opposites, and if I add them together, the x's aren't going to cancel out. Here, these are opposites, and if I add them together, I'm going to get 7x here, and same thing here. I kind of told you if you multiply by -2, the y's are not going to cancel out. So here we would have B would be the answer. These two lines would be parallel. They'd end up with no solution. So you kind of got to try all of your choices. On number 5, what is true about the graphs of the two lines below? Okay, so if we were to graph these two on a coordinate plane, are they going to have no solution? Are they going to intersect at this point? Are they going to intersect at the origin? Or are they going to have infinitely many solutions? So I have to solve the system. And looking at them both, they're written in standard form, even though this one has a negative coefficient on the x term. But I could solve them using the elimination method. So if I look here, this is a -6x. I could easily make this a +6x just like by multiplying everything by 3. And then I'm just going to rewrite that right down here. So multiplying everything by 3, that would give me 6x plus 9y equals 3 times 4 is 12. And then if I go ahead and add them together, the x terms are opposite, the y terms are opposite, giving me 0, and -12 plus 12 would give me 0. And so therefore, I would end up with a true statement, an identity, infinitely many solutions. These two equations are exactly the same. Did you notice here that if you were to Well, triple everything. Like if I multiplied everything on this equation by -3, I would get this exact equation. Or if I divided everything here by -3, I would get that exact equation. If we rewrote them both y equals mx plus b, they would be the exact equation. All right, on our last one, number 6, determine which system has one solution, no solution, and infinitely many. So we got 3 systems here, and we want to decide which one is which. So I'm going to have to solve them, and they're all written in standard form, so it would make it really easy to solve just using elimination method. So I don't know, which one should we do first? Now, this one looks pretty easy with the x and the y here. In order to get the y's to cancel, being that they're already opposites, there's a positive and negative, I could multiply the top by 4, and then I'm just going to write that right below. So 4x plus 4y equals -28. Okay, so I'm going to add these two together. The y's are going to cancel out because they're opposites. 3x and 4x make 7x. -28 plus -28. So -28 plus -28 is going to give me -56. So it looks like I'm going to get a solution here. X equals -8. So we are going to get -8 for our x coordinate. So this one's going to be the one solution. So I've used up that one. But now I have to substitute back in. I'm going to plug the -8 back into this equation right here. So I'm just going to pull that down. X plus y equals -7. And I'm going to plug in x's -8 plus y equals -7. Add 8, add 8, y equals +1. So I'd have -8, +1 for my solution. So that's one solution. The x's don't cancel, or the x and y's didn't cancel. So we had a definite solution there for that one. Okay, let's go to the middle one. Let's try this one. Well, notice on this one here, the 3 and the -15, if they're both 15, this was +15, then I could get the x's to cancel out. But notice here too, if I multiply by 5, the y's are going to end up canceling out too, aren't they? Can you see that? Let's go ahead and write it right below. So I'd have 15x plus 10y equals 5 times 8, which is 40. So I go ahead to add these together. The x's are opposites, they cancel. The y's are opposites, they cancel. So you get a value of 0. -40 plus 40 gives you 0. So here I end up with 0 equals 0, which is true, and it's an identity, so this would be infinite. Infinite solutions here, which means that this one's probably no solution. Let's check it out. Let's see if you can remember how to solve this here. Looking at that 4 and 14 might not be as easy to see what our least common multiple is, even here with the 6 and the 21. But if I think about like doubling the 21, that's 42, and 42 is a multiple of 6. 6 times 7 is 42. So I can make these both 42. The top here, I can make multiply by 7, and that would make this a -42. But the bottom here, to make it a +42, I'd have to multiply by -2. Kind of a little bit harder to see. So let's rewrite. I'm going to rewrite the top one right down here. So I'd have 28x minus 42y equals 7 times 5 is 35. And down here, I'd have -28x plus 42y equals -2 times 15, which is -30. So now when I go ahead to add these two together, do you see how the 28s are opposites? The 42s are opposites, giving me 0, and 35 plus -30 would be 5. So I would have a not true statement, and so this one would be no solution. So solving using elimination, getting no solution, infinitely many, or one solution. All right, let's go ahead and summarize. All right, so if I'm solving a system and my variable x and y, if they cancel out, the variable cancels out, and I'm left with a not true statement, then the answer would be no solution. And if the variables cancel out and you're left with a true statement, like 0 equals 0, then the answer would be infinitely many solutions. All right, thank you for joining me for lesson 6.3b, and have a great day.